All right, hello everybody. It's Ham Solo here, Kilo Zero, Foxtrot Yankee Romeo. I have delayed quite a bit due to a lot of different factors, but I am ready to finally edit and post this video. This is a follow-on to a video that I made last year, actually, where I was trying to test out a piece of equipment for work. What that piece of equipment does is basically it's an area monitor that looks for different gases in air. So chlorine, ammonia, hydrogen cyanide, hydrogen sulfide, CO, so forth. Mainly what we use it for is radiation. It does have a radiation detector in it. And so when we set this meter up, we usually do it at venue sites for, let's say, like a concert or the World Series or the Super Bowl. And we monitor radiation signatures that might be coming into the venue looking for bad guys. That's kind of the idea. And so normally what we use are vertical antennas, and someone suggested on that previous video that I try a polarized antenna because I wasn't getting the distance that I was looking for when I tried to hook up a Yagi at 900 megahertz for this system to work. And so the system uses the ISM frequencies at 900 megahertz. I think it's somewhere like 902 to 930-ish megahertz. And so I was trying to use a 900 megahertz Yagi to extend the signal out more than a half mile, maybe to 2 miles, 3 miles, and so forth. And the Yagi didn't seem to function right, like I expected it to do, with 6 or 7 decibels of gain going towards where we would have the meter placed. And so this is a follow-on video for that, but this has been quite delayed. So it did take me a while to order a part. It did take a while for me to start recording the video, but I haven't been able to edit it for another probably 6 months. So this is like a year that this has been going on from when I did the first video for this subject. I will put a link up top to that original video. And then this next step is going to be all the follow-on that I did with the circular polarized antennas to see if I got a much farther stretch for some reason with the 900 megahertz. So stay tuned. This is going to be that video. Thanks. All right, so ran into the first hiccup. Came out here on the road. This is 3 miles from where I have the meter set up. There's the circular polarized antenna. I still have the Yagi on there, just haven't taken it off yet. Ran into an issue already. The circular polarized antenna, even though I ordered the cable to have, I believe, the male TNC connection on it, what was sent was the reverse female. And I don't have anything to mate that to the reverse female that's on top of here. And so I need like a bladed male going to an insert male for this one. I don't know where I can get something like that. I'm trying to think about it. All right, morning everybody. Ham Solo here, Kilo Zero, Foxtrot Yankee Romeo. It has actually been 6 months since I recorded the first part of this video. And some of the problem was I didn't have the right connection that would go between this host right here. See if I can get it in the shot. And that antenna that I'm going to have out here on the deck. So I had to go back to Elcom and I had to order an adapter to be made so that it had a male on this side that has the actual post in the center, and a male on this side that has a post in the center, in order to get between the antenna itself, the circular polarized antenna, and the top of this actual unit. And so it took a while for that to come in. I want to say the better part of probably 2 to 3 months for this adapter, which is fairly short looking adapter, but it took about 3 months for that to come in. And then I had obviously the surgery that I had on my Achilles, and so that had kind of laid me up after that. And so now I'm finally ready to try to get these things to connect and read, so I can do the test at 3 miles, so I can do the test at 5 miles, and see if the polarized antenna is going to work. So let's get this hooked up and make sure that it's reading on the unit and on my laptop, and then we can proceed to go out and try it in the field. All right, good morning, everybody. Ham Solo here, Kilo 0 Foxtrot Yankee Romeo. I am doing a test again for a work type application. And so, done this test before. I'll probably put the link up here in the video of where you can see where I tried to do this communications with this gas detection unit using a 900 megahertz Yagi, and I didn't seem to get any better reception or distance, even with all the decibel gain, compared to the regular antenna. So it was suggested by someone in the comments that maybe I should try circular polarized, because with 900 megahertz, as the signal goes out, it may be vertical, and then as it hits something, it goes horizontal. It hits something and it goes vertical. And so it keeps changing polarity as it bumps into objects. And with the terrain that we have here in Colorado, or if I'm setting this up at a venue monitoring site, let's say at the Super Bowl, and I have buildings and parking garages and so forth around, it would be changing polarity in that event as it struck those objects. And so the suggestion was that I grabbed some panel antennas. And so I picked up a panel, 900 megahertz panel antenna from Elcom. And this one is left-hand polarized. And then I have the other one down here that is right-hand polarized. And to find out which way the polarization is spinning, whether left or right, depending on the inversion between horizontal and vertical. So I have the unit sitting here. I was running a calibration with the unit, and I'm going to set that up, and then I'm going to travel to the same places I did, which is going at about 3 miles, and then going into Mueller State Park and setting up in the visitor center parking lot. That should be 5 miles, and see if I get any better reception than I did with the 900 megahertz Yagi. So some people ask, well, why is this important? So we just saw with the 2 hurricanes in Florida, communications get knocked out. I know that there's several new type of radios, like the rapid radios, that are doing the LTE network in order to keep you connected, kind of like a Nextel type of walkie-talkie type deal. Some of them use satellite, very few. And so the rest of them are just kind of regular radio wave. And so knowing that we're going into disaster areas where the fire service or emergency rescue services might be employing these monitors to look for decaying plant material in floods, we look for hydrogen sulfide gas. Sometimes at the venues, we're looking for ammonia, chlorine, those kind of things. We also have radiation detectors, and all that data gets transmitted back to a host computer. And so in order to get that data transfer, when you're going into those disaster sites where all cellular communication is knocked out, the potential that all of the internet-based trunking systems may be out, then we go back to just standard radio waves. And in this case, 900 megahertz, this is the ISM frequencies, industrial, scientific, mathematical, or mechanical is what I'm thinking it is. And so we're just going to try to see, can I extend the range of this from anywhere between 2 to 3 miles upwards of 5 miles or more using those polarized antennas. All right, so I'm out here on the deck. I have the new attachment piece, so I'll go ahead and open that up. Nice. So the first mating that I'm going to try is going to be from the actual antenna. And so this is a TNC, and it's a female receptacle, and I had to get a TNC male type receptacle to go into it. So We'll try that matchup. Perfect. Screwed right in. So now I got the jumper on there. And it's going to go to a different type of screw connector that is a female. And so this one had to be a receptacle with the male prong in it. All right. Let's get that hooked up. And it went in perfect. So this is the very first time that this antenna is going to be connected to the unit and the software. So turn on the radio here. This is the host radio going to the antenna. Circular polarized. I believe this is right circular. I'm going to just set that on my banister here. It's quite windy today. This is the beginning of spring, and so we have quite a bit of wind coming through. All right, so I'm going to start up the software and we're going to see what we get. All right, so I started the software. This is the software running. I'm going to kind of turn the camera around here in a second. And it's immediately reading, immediately have a gateway connection. The antenna is working with the adapter. And so all is good. I am ready to proceed out to the field. But let me turn the camera around so you can see what I'm talking about. So I got a little bit of screen glare. And you can probably see me in the reflection. But basically, I've got where the house is located. I've got the GPS coordinate is on. And I'm getting my readings automatically for oxygen percentage, lower explosive limit, hydrogen sulfide gas, and carbon monoxide. And so normally we would have different meter setups here, depending on the type of venue that we're monitoring. We might have chlorine or ammonia sensors, or in a lot of cases with our venue monitoring, probably a radiation sensor. Right now I just have a generic, we call that a 4-gas mix. And that is for when we're doing, let's say, overhaul during fires. And so that's the type of gases that we're monitoring for. So I have a GPS location on the unit itself that's sitting here on the chair. And I've got the gas readings that are coming through to the host from the antenna. And so now, ready to go out and try the experiment at 3 miles. All right, I'm out on the side of the road. I have the laptop here in the car, and I've got the antenna set up right here with the Raylink sitting on it as the host, and I am not getting a signal at all at 3 miles. Unfortunately, I didn't bring my hotspot, and so I'm trying to use the Wi-Fi off of the car, but it's not even uploading the map. And so I think that it doesn't have a good internet connection, which shouldn't affect the 900 megahertz radio, other than this program, unfortunately, is an online program. And so you got to have internet in order to see this cloud-based version of the software. So I'm going to have to try it again. And see if I can bring my regular hotspot out instead, and see if I get a better connection. But right now, this didn't work. All right, I've set back up again. This is on about exactly 3 miles from my QTH, or my house. And we got the antenna on top of this mast. Actually, the circular antenna is on the ground. I'm trying the Yagi. I wasn't getting any connection at all. And so I just realized that I probably have to update the internet gateway that is going to the program, because the program itself was updated last night. And so I think my gateway that gets into that program was out of date. Kind of a proprietary system that comes from Honeywell Ray Systems. And so going through the process of updating that, as soon as I get that finished, then I'm going to try the Yagi first, because I know I get connection at 3 miles with that. And once I know that that all works, then I'll go ahead and try the circular antenna again. All right, got the device updated, got the gateway updated. Now have it connected to the Yagi antenna. So there's the Yagi antenna. The circular one's just sitting there on the ground. I've got the host Raylink is on. If you can see it, it's right here. I have the computer program on, and I am receiving data. So the area array that's sitting on my patio. Oh, you can't. I'm sorry. Let me turn the camera. The area array that's sitting on my patio is that image there, and I'm getting OK status. I'm picking up CO, O2, LEL, and H2S readings, and so I do have it connected. Still not getting the map, and so need to check in on that. But right now, the thing is connected with the Yagi. So let me switch over to the circular. You can see that there are no results. There's no data showing. There's no results. I'm not getting any signal from the unit here, which is the host, up to the circular polarized antenna. Now the antenna is moving back and forth quite a bit in the wind, but I'm not getting any data. And so I do have the Raylink on. I can see the Raylink when I go to the gateway. So let me pan down. And so it is picking up the Raylink, and it has the Raylink serial number. And so it's reading the Raylink, but the Raylink is not receiving any data from the antenna to the unit like I was on the Yagi. So let me make sure that something didn't happen. I'll switch back to the Yagi cable, and we'll see what goes. All right, so wind blew over the mast. I have it set up right now with the Yagi again, and I just picked up signal, and so I have the data coming in from the program with the GPS location, and so I am able to see it using the Yagi antenna at 3 miles. I'm going to try the circular antenna one more time. It took a while for it to establish connection, even on the Yagi, so let me try with the circular rotation, and then we'll go from there. I got it hooked in again, and I've got no result, and that is from the Raylink to the circular polarized antenna. I tied that to the mast so it wouldn't swing around, and it's facing direct to where my area array is sitting on the patio, and I am getting no result at 3 miles. All right, on a whim, I decided to test out the other polarization. And so before, I was using a right-handed circular, which was this one. So right-handed circular polarization, and now I have a left-hand circular polarization, and I still see no data. So there's no data on the device. I'm going to turn the camera around. So I've got no result, no data on the device using either the left hand or right hand polarization at 3 miles. So no data, no results. All right, just to try it out, I hooked the Yagi antenna back up and got the Raylink sitting there on the ground. And I am pulling data from the machine. So at 3 miles, the Yagi is working, but the left and right circular polarization is not. All right, no data. And this is at 4 miles out with the Yagi. So this is probably going to be the end of the test. I moved out 4 miles. I got the mast up. I've got the Yagi on the top, plugged into the Raylink, and unfortunately, I'm not able to get a signal at 4 miles. And so the circular polarization, left or right, didn't work at 3 miles. And the Yagi, which did connect, now won't connect at 4 miles. So
It could just be that the 900 megahertz radio that's inside of that area array is just not putting out a lot of wattage. I believe it was not that much to begin with. Anyway, I don't have the data available on the top of my head, but I know it wasn't more than maybe milliwatts to 1 watt. And so at 3 miles, I'm able to pick it up with the Yagi, but that's it. And at 4 miles, nothing. And so this is probably going to be the end of that type of testing. Thought maybe there'd be a difference with the circular polarization. It was not effective at all. And so, don't try that at home, kids, because that's not going to work for this 900 megahertz ISM on the area array. And other than that, the Yagi, good up to 3 miles, but I think we showed last time that you could use the rubber duck on the top of the array link and still get 3 miles. So don't really see a benefit in having the 6 decibels of gain with the Yagi if the omnidirectional rubber duck is going to work the same. So unfortunately, this test did not work, and that's going to be probably the end of me trying anything like that with this type of radio. Till next time, this is Ham Solo K0 FYR 73.